Welcome back to the channel. So in this video we are going to dive into very popular linked list problem. This is Leetcode 141, as you can see, right? And this problem is very popular in the list of linked list problem, right? Where this Leetcode 141 is very famous if you are preparing for coding interviews. So this is one of those must known problems that tests your understanding of pointers and linked list traversal. So we are going to understand in this FAANG interview preparation series. So I have already uploaded a couple of videos in this playlist. So if you have not gone through, please go and watch that. This is a medium level and very conceptual questions that you may not know, or you may be aware of that, but will understand very quickly all the basics questions. Okay, so let's get started. Linked list is a linear data structure that is made of connected elements that is called nodes and arranged like a chain. Okay, so each nodes, as you can see here, having two parts, the val and the next. So a val is a you can say actual data. Let's suppose 3 5 7 are actual data, and these are the next is a pointer that links to the next node in the sequence, right? So the last node that has its pointer is null, it's called the end of the list, right? So this node is the last node, and in the another list concept of cyclic is connected with the next node like this, you can see, right? So there is no end, right? So as you can see here, right, we are seeing that the last node having null, but when you are coming to this one, you cannot see that there is a next null, right? We cannot see, and that is why this is called cyclic linked list. Okay, so cyclic linked list and single linked list, the difference is that there is no cycle in this, right? But in the cyclic linked list there is a cycle where no last node you will find in the list. Okay, you will not find any last node. Okay, so how the single linked list is working, right? So let's suppose to traverse the linked list, right? First of all, we have to start from the head node, and that is called the first node, right? And we'll use the next pointer to move to the next node, right? As you have seen in the node, right? The linked list. So each node, right? We will start from here and we'll keep checking the next one, right? So we have to start there will be a head node that is called the first node, and we'll use the next pointer and we'll move the next node, right? And we'll continue this until we get the next is null. So once we will get the next is null, right? Next is null means this is the last node, right? Means we have to traverse like this. Means the key point is that there is no cycle. Means in the single linked list, if you're traversing, means you will not find any cycle is there. The list has determined start and end, right? There should be a start node and there should be an end node, right? And the traversal stops when the last node points to the null. Let's suppose the next one that we have is cyclic linked list. So as we told, there is no last node and each node is connected with the next node, right? And so it forms a cycle. So what is a cyclic linked list, right? So a cyclic linked list is a variation of a normal linked list where the next pointer of the last node doesn't points to null, right? Instead of it points back to one of the previous node that forms a loop or cycle in the structure, and structure of the each node will be having the val and next, as we have told earlier, right? Similarly will have, so there will be val next will point to the next one like this, and it will back, it may go to the first node, right? So if you represent you can say a couple of nodes, you can say, so this was the you can say in the cycle, right? But in real, what is happening, there is a val next, it points to the next node. Similarly this next point to the next node, but this node is back to going to the previous node, right? So that there is no last node is there, right? And so it forms a cycle like this. I hope you understand, right? So how traversal works in the cycle linked list, right? To traverse a cycle in the linked list, right, we will start from the head. You can take a head, and we have to follow the next pointer as usual, but this time you will loop forever unless you add a logic to detect the cycle. So you can imagine a small pointer moving from node to node, but instead of stopping at null, it keeps going in a circle because there is no end, right? Means let's suppose we'll start from here, right? So we'll go we'll find to the next node, then we'll find the next node. Like this, we'll find the next node. So you will go into a loop, right? So you have to find a way where you will not traverse this again. Let's suppose we'll mark this node as a visited, right? But will this concept will work or not, that we will see in the further in the video. Okay, so you have to take a small pointer and you have to move node to node, right? But instead of stopping at null, it will keep you going in the circle because there is no end node, right? So why this matters, right? Why this cyclic linked list is working, right? Why it is in demand, right? So just understand that linked lists are useful in certain applications like round robin scheduling. I'll create a video on this. I think in my notes the round robin scheduling. I will put one video on this one. But they can also be used as infinite loops, right? Let's suppose if you will not properly use the cyclic linked list, right? So you will go in the infinite loop, right? If you are not careful, right? So it's important to detect a cycle before traversing endlessly. That's exactly what problem like we have Leetcode 141, the linked list cycle, right? That will practice you, right? That will help you to practice, right? And to understand the round robin scheduling. So in the next video, I'll try to cover the round robin scheduling, right, in this series. So let's continue further. Okay, so it's time to understand the problem, right, of this video, right? So I have just given you the background how the linked list is working and how the cycle works in the linked list, right? So I hope you understand the cyclic linked list and the single linked list. Okay, let's understand the question now. So here is the problem that we have given a head, right? What we have given means you are given the head of a linked list. Let's determine if the linked list has a cycle in it, right? Means what is your job? Your job is to determine if there is a cycle in it. Okay, as we have discussed earlier, you have seen the cyclic linked list, right? Means you are given a head of the linked list, right? And your job is to determine if there is a cycle in it or not. Okay, so further it is saying there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer, right? So internally there will be a pos, there is a position is used to denote the index of the node that tells next pointer is connected to. But it is also giving note that the pos means position is not passed as a parameter, right? In the function we have not given these things, right? So you have to return true if there is a cycle in the linked list, otherwise say there is no cycle in the linked list, yes or no, right? Means what we have given, first of all we have given the head of the linked list, right? And our job is to determine if there is a cycle in it, right? So a cycle means that at some point a node's next pointer points back to the previous node, right? That will create a loop in the list and it will look like a cycle. Understand? So let's look at this example, right? So we have given head in the example. The problem is saying that we have given head, right? What problem was given? The head of the linked list. So this is the head of the linked list. What is the head of linked list? If you will find the head of, if you have given the head of linked list, means you will have the data, these three, and the next pointer information, right? So next will connect automatically to 2. As you can see, we have 3, then the pointer is saying next we have 3, then we have 2, next node we have 0, then we have next pointer -4. Like this, if you represent this, it will become like 3 2 0 -4, right? Like this. But it is saying there is a pos, there will be a pos 1, right? So let's suppose if we have given the pos 1, right? If we have given the pos 1 means this is at 0. Let's suppose we'll count it from here. So this is like, let's suppose as an array we have given, so we can say this is sorry, head we have given, so we can say this is index 0, we will say index 1. So at index 1 means the at node 2 there is a cycle, right? So is it correct or not? If yes, return true, otherwise false. Okay, so there is a cycle in the linked list where the tails connect to the first node, that is 0 index, right? So at 0 index, if you see here, there is a cycle like this, right? So this will become a cycle, right? So if the pointer comes to the node 2, it from 3 to 2, it comes smooth, but when it is coming to 2, it will go to 0, -4, it will back to 2, again it will go 0, -4. So it will keep going like this, it will keep going, right? Means it will form a cycle and it will never ends, right? So this is true. Now understand example 2. Why I am showing you all the examples? Because it is necessary to understand. Before writing the code, you should understand the examples, right? Another example we have given, head 1 2, right? So in the previous you have seen there is a couple of nodes are there where positions we have given not at the first node, but it's going to the next node. So you can easily traverse from this node to here, but once you are going to this node you will form a cycle and you will never comes out from here, right? Similarly, we have given a smaller head, right, linked list. So you can say we have given 1 and 2, right? So at position 0 it is saying that we have to form a cycle. So as you can see, pos is 0 if it is 1 and 2. So is it possible if from the position 1 we can make a cycle? Yes, that is true. Okay, now it's time to understand for 1. So first we have seen a couple of nodes was there, then at least 2 nodes is there. Now let's suppose there is only 1 node is there and we have given pos is -1, right? So -1 is not possible in this case, right? Because there is only 1 node, right? So we can take as from the 0 position, but -1, how we will go there? Okay, so there is no cycle in the linked list. You can say there is only 1 node. So if you mark it, it become like only 1 node is there, right? And so we'll say it's false. Now understand the constant, right? So number of nodes in the list is in the range of 0 to 10 to the power 4, and similarly the nodes value will range like this, and POS is -1 or valid index in the linked list, right? So the question can be asked further once you will solve this problem. Can you solve it using O of 1 times, that is constant memory? Okay, I hope you understand, right? Coming back to the example first. Okay, why I'm coming back to the example first? Because you have to understand the example. So let's look at the example again, right? What we have given, head we have given 3 2 0 -4, okay, and the position we have given is 1. So here at position 1, right, here at position 1 means that tails connects to the node at index 1, right? So at this index 1, the tails is coming from -4 and it's coming back to here, right? The tails connect back to the node at index 1, means this node with value 2, right, it connects all the tails coming from the this node -4, right? Means the list loops back to this node, right? At that node, you can say. So our task is to return true if there is a cycle, otherwise return false. So when the pos is given, we have to check that here PO at the pos 1 means at this node, right? Means at POS 1, pos 1 means at this position 1, means that the tails connects to the node at index 1. Index 1 is this node, which is the node with the value 2. So the list loops back to that node. Okay, so what is our task? We have to return true if it's a cycle, otherwise return false, right? So just think about what will be our approach. So there will be one approach is to store all these visited nodes in a hash set, right? And we'll check if we will visit any node, right? But this will take extra memory. Which extra memory? Because if we have traversed, let's suppose node 3, we'll put into a hash set. Okay, means to store in a set, we have to create the hash set, and hash set will take the memory, right? But the interviewer can also ask, can you solve it using O of 1 time, right? The constant memory. right? And that is why you should not use the hash set in this case, because the follow-up question is saying that can you solve it using the of1. But let's suppose the first time that you are writing the code, you should try by hash set. So in this video, what I will do, I'll give you a task. What is the task? You pause this video till now and try the approach that you will store all the nodes, right? All the visited node means let's come back to here. So all we have, you should store all these visited nodes. Let's suppose 3, 2, 0, -4 these nodes in a hash set and check if we visit any node again or not. Let's suppose you have added 3 in the hash set, right? Okay, fine. Let's move to the next node. Next node is 2. You will put into the visited set, right? Then we'll go to the 0. Then you'll move to -4 like this. So all these are you have added till here. When these tails connect back to the node 2, right? Means this node 2 value is already in the set. Means as you got that this is already in the this node is already in the hash set, right? It means there is a what? There is a cycle, right? And then we should return. So this question has been asked in the top companies, as you can see, right? So this is the preparation series of FAANG. So as you can see, the FAANG in 0 to 3 month has asked this question. Google, Amazon, Meta, and many top companies also have asked this question, right? So this is very important. So I have included in this playlist, and I'm also tracking all the companies, right? So what I'll do, I'll keep adding the playlist based on the current situation in the market, right? And I'll do research that what are the question has been asked, right? And I'll keep adding the videos in this playlist, so you will be aware. Let's suppose you are going for the interview, so you should be aware with that these question has been asked, and it will help. The problem statement is saying that we have given a head of the linked list, and our goal is to detect if there is a cycle exists in the list or not. So the cycle is the next node, right? That is called node's next points back to the previous node, means we will get the cycle, right? So we have already discussed. So let's understand a cycle in the linked list means a cycle occurs only when a node links back to the previous node, and this create a infinite loop. We have given this heads and this pause we have given. So pause at 1 means that node 2 the tails connect back to at this index 1, and so the node with -4 having a links that is next point back to the node with value 2, right? And that is why it formed the cycle. So if the result exists means result having the cycle exist. In this case, the expected output should be, if the cycle is detected, return true. If cycle is not detected, return false, right? So how we are going to detect cycle in the linked list, right? So let's understand the approach. So we have understood that naive approach will use where we will use the hash set. We'll store all the nodes in the hash set and will repeat it until we'll visit, right? So when we are going to check for the repeated visit, it means we have already traversed this node, and we'll say return back means there is a cycle in the list. Okay, so the drawback is that it is using extra memory to create the hash set and visited nodes, right? Now understand the optimized way. So there is a concept that is called Fred cycle algorithm, detect cycle algorithm, right? And it is also known as Toterize and Hare algorithm, right? Where we'll use 2 pointers, slow and fast, and there will be no extra space used. Okay, so let's understand the 2 approach, that is Fred cycle detection algorithm, also known as Toterize and Hare. So this is Toterize and this Hare. You must know of this is the known concept, right? So let's understand here. So if we are using 2 pointer, in this case slow and fast, so slow moves 1 step at a time and fast moves 2 steps at a time, right? So if a cycle exists, right, both pointer meets inside the loop, right? If no cycle is there, means fast pointer reaches null at the end. Okay, so this is the algorithm. Let's suppose the tortoise and the hare start from here, right? As soon both are starting at the same point, right? This tortoise will go with the only one node traversal, right? But the hare will start from here, but it will not go here. It will jump to the next node, right? Here. When tortoise reaches to here, right? He reaches to here, right? Next point, when the tortoise move here, the hare will already here. Now it will not go here. It will come back to 2, right? So as he reaches, the hare reaches to here, he will jump to here at this index. And then we both will meet here. It means what? There is a cycle and the hare doesn't find the null, right? Means the first pointer, this is null, means this is no cycle, but it moves to the infinite loop, right? But it reaches both meets at this position, right? So we can say this is a cycle. If a cycle exists, means both pointer meets inside the loop. So inside this loop anywhere they can meet. Okay. So what we will do, we'll initialize the 2 pointers, slow and fast, both start at the head of the list. Then we'll move to the pointer, slow moves 1 step at a time, fast will move to two at a time. And then we'll traverse the list, we'll repeat the same thing. The fast is null, no cycle, slow equal to fast, cycle detected. Okay. So I'll show you how to do this in the example. Okay. So let's understand the example. Okay. So first of all, how will this work, right? Before writing the code, these two things we have given, right? First, the class name we have given, and the cycle we have given, cycle method we have given, right? It is saying that we have given the head, nothing, no pos was we have given here. Okay. So if pos is not given, the position was not given that this is index 1, we should check that there is a cycle. So that is not given. We have only given the head of the linked list, right? And if there is a cycle exists, we will return true, right? So how will this work, right? So as you know, the FAANG algorithm, I told you, we will use 2 pointers, slow and fast. Slow is tortoise and fast is hare. Okay. So let's understand. So first of all, let's suppose why I am taking the first condition as a head equal to null, head dot next equal to null. In this case, we'll return false. Why? Just think. So first we will check, right, if the head or the next node is null. Let's suppose there is only one node, this node. As I told you, we have gone through multiple nodes, right? Multiple example 1, 2 and 3, right? So in this we have 4 node. The example 2 we have seen 2 node, and there is one node also, right? So let's suppose there is only one node, this node 3, and head is points to here, right? Heads points to here, right? Means from heads we can go to all the nodes, right? That is why we have given heads here. Okay. So we can traverse to the next node like this. Okay. So head we have already given, right? What we have given? Head we have given. Let's suppose there is no nodes are there, right? Only 3 is there. Okay. So first we should check if the head, right? If this head or the head or the next node is null. Either this or this having next node is null, right? Either you can say this node, the head or the next node, both are null. Okay. Either of them are null. Let's suppose this node is null or this node is null. Means we'll say there is no, if there is no node, right? If there is no node, in this case also the head is null. So either head is null or its next is null. Means there is no cycle, right? If there is only one node, there is no cycle, right? If there is 2 node, right? And this 2 node, second node, the head dot next is null, right? The head that is given, right, itself head dot next, this is null. How will you make the cycle? There is only one node, right? Either this node is not there or there is 2 node, but this node points to the another node having null. Means there is no node is there, null is there. In this case, we'll return false. I hope you understand, right? Means first we will check if the head or the next node is null. So in this case, there is no cycle, right? And so if there is no cycle, we'll return what? We'll return false. I hope you understand this point, right? The step 3, right? The step 1 itself is at 3, right? So this step will only check if the head or the next node is null. It means there is the node itself is null or it points to the null node. Will return false. There is no cycle. Understand, right? Next, think about what we should do, right? So we are doing what? Flat algorithm, right? So we should use 2 pointers, right? Slow and fast. Slow is tutorize and fast is here. So let's suppose this is our tutorize, right? Where we will use slow will also start from head. Means I told you, right? Tutorize and here both will start from where? Head. Then it will move to here. Then it will move to here. Then here. But the tutorize will go one by one, right? But the head will go from what? One more, it will skip one, it will go to one more jump. They will take the one jump. Okay. So both slow and fast, tutorize and here, both will start from the head here, from here. Okay. Means the we will use slow and fast 2 pointers we will use, right? Means we have to initialize these 2 pointer. In the first step, we will check if the head and the head dot next is null, means there is no cycle, return false. Then in the next step, what we will do, we'll initialize these 2 pointers. When we will initialize these 2 pointers, the you can say tutorize and here are ready, right? Slow pointer, fast pointer, you can say. So these 2 pointers are ready. Now we'll take you can say how we are going to move, right? So slow will move one step, this slow will move one step, one at a time, and this fast will take 2 steps at a time, right? So how we are going to do? So we'll take the loop, right, and we'll move them at different speed, right? Means the first will take what? We'll check the head is null, our head dot next is null, means there is no cycle. Then we'll take 2 nodes, 2 pointers, right, here tutorize and here, and we'll initialize from the head, means from here. So let's suppose this is the head we have given, and so both tutorize and here, means slow and fast pointer will start from here. Now what we will do, we'll take a loop, right? We'll make a loop of these nodes, right, and we'll move them at a different speed, right? What is the speed? So the slow will start one step at a time, slow will moves one step at a time, and the fast will move 2 steps at a time, right? Means let's suppose this is tutorize here and here, both are here. So tutorize will take 1 step like this, right, like this, but the here, that is the fast pointer, will start from here also, but it will not go here, it will go from here to here, then not here, it will come back to here, like this it will go. So if there is a cycle, they will meet eventually inside this loop. How? So while fast not equal to null and fast dot next not equal to null, so slow will always be behind the fast, right? So we will take the faster node, right? Means here, not tutorize, the fast pointer will take here, it should not reach to the null. If it is reaching to the null, means there is this link is not there, means we reach to the last, right? If the fast is not null and fast dot next is not, let's suppose this fast is here, right? So fast dot next, if it is reaching here, right, then fine. But if it is reaching the next pointer, that is there is no next node is null, right? It means we have to stop this loop, right? So if there is a cycle, they will meet eventually in the list, right, in this loop, right? Otherwise what will happen? It will reach to the fast will reach to the null, or fast dot next will reach to the null. Only these 2 conditions will happen, right? So in the loop we'll move them at different speed. So what is the speed? Slow is equal to slow dot next, means one step it will move, right? And fast will take from fast we'll start from here, right? So fast will go next to next, right? So we'll take next dot next. Now if both meets, right, if both meets, what does it mean? Means there is a cycle. If anywhere the slow and fast reaches, right, means they meet, right? So slow and fast will meet inside the loop. So in this loop, if both are meeting, it means there is cycle, just return true, cycle detected. Else continue it, right? It means you have to come out of the loop, right? In the while loop, you will come out. If otherwise, what will happen? There is no cycle. Once there is no cycle, return null, right? There is no cycle, right? And then we'll close the cycle, right? Means what we have taken, these two loop we have taken, we are the slow will go one step ahead and fast will go two step ahead. If both meets, means cycle detected, otherwise cycle not detected, right? Means we will get, we will not meet at here, but at some point we'll find null either at fast or fast dot next. If we will hit, if the fast will hit the end, we will get the end at null, means fast is reaching at null, yeah, fast dot next is reaching at null. It means there is no cycle, right? Means if they ever points to the same node, right, means we'll say in this case like this, it will go like this and it will hit this. Means if they ever points to the same node, will return true, right? If the fast reaches at the end, it means no cycle, we will return as false, and that we are doing here. I hope you understand, right? Let's suppose we are going for all the nodes one at a time, right? So in the worst case, we'll go for all the node. Let's suppose there is how many nodes are there, right? In the total nodes are n number of nodes, right? N numbers nodes in the head. So if you talk about the complexity, right, we will visit all the nodes, right? We are visiting all the nodes. So in the worst case, we are visiting all the nodes and we'll say it will take O of n time, number of nodes we have to traverse. We are not taking any extra spaces here. We are not storing anything, not visited one, nothing, right? So we don't use any extra memory, and so we just use two pointers, slow and fast, using the FLAD algorithm, right? FLAD cycle detection algorithm, right? This is tutorize and this is here, right? And so we will use O of 1 time for the space and for the time O of n, right? This help you. Give it a channel for more coding tutorials and drop a comment if you want me to cover any other Leetcode problem. Practicing, keep coding, and please subscribe the channel.